So what we're going to do today is changing quadratic relation, which is the value of a. So we're gonna define a few things first, because we need to know what these points mean. I already talked a little bit in the intro about all these different points, but I would also like to recap them with you today, and then we'll move on to the value of a. What does it do to the graph? So we're going to start with a quadratic relation is modeled by a smooth symmetrical curve known as a graph. So the key features of parabola, of course, the zeros, right? The zeros, or there's many names for them. Do you guys remember the names?
Roots.
X-intercept, roots, solution, solution. Okay? So the zeros are right here. Okay? So where that graph touches the x-axis. Okay? So the zeros, there's two of them, or one, or nothing, or none. Okay? Remember we talked about that yesterday. In this case, I have two. The way that we label the zeros, there's two different ways that you can label them. You can write them like this. So x-intercept equals to, I'm going to call them R and S because you'll know why later. Okay? But for now, I'm going to just label them as R and S. So the x-intercept R and S. Okay? You see that and is important. We don't write R comma S. That's not right. Okay? We have, when you're labeling it, when I ask you what are your x-intercept, you're going to have to put the values with an and in between. Okay? So in this case, for example, it's -1, -1, and 1, 2, 3, and 3. So the way I would write it, x-intercept equals -1 and 3. Is that clear? Mm-hmm. Okay. All right. Now this is one way you can write it. Another way would be by writing them as points. Okay? So by writing them as points, you would put R, comma, 0, and S, comma, 0. Okay? This is how we write a point. A point has x and y value, right? The x value is the R, and the y value is going to be a 0 because it's on the x-axis. And then the next one is S and 0. Let's include the values here. What would it be? -1, 0, and 3, 0. Okay? You can pick which way you would like. You don't have to write them both ways. Learn one and learn it well. Okay? Either way. So the definition for the x-intercept is where the graph intersects the x-axis. Okay? You'll see that in different ways. Yeah?
If you write it in the point, you just have to put x-intercept for?
No. Only when you're writing it as a value. Are we good with that? Now, moving on to the y-intercept. Obviously, the y-intercept is where the graph intersects the y-axis, right? So let's write here. you're writing y-intercept, you write it as y-intercept equal to the value. I'm gonna call it C. And I'll tell you later. You'll know why I'm calling it C. It has to do with this. Okay? But we'll discuss it later. Another way that you can write that is as a point. So it's gonna be 0, C. The location of the 0 and the value is very important. So let's write the example. So y-intercept equals to, I think that's -4 here. Okay, see that it says -4. Or we can write it as -4, sorry, 0 negative. Again, you can pick one of these methods. You can either pick that or write it as a point, which is 0 negative. Whatever is easier for you. Okay? And the definition for it is where the graph intersects the y-axis.
When we put in the answer, we write down most of the time the reason why the reason you came up with that answer? Based on the graph?
No.
Or?
You just have, basically I will give you a graph and I'll ask you what is your y-intercept, what's your x-intercept, I'll ask you for them, okay? And then you just have to include the value. You just have to write this or this. The vertex. What's a vertex?
The middle of
The turning point, right? It's a point where your graph either turn this way or that way, right? So in this case, they gave you two different examples, right? So this is the vertex, okay? The vertex is a point. And the way that you're gonna label the vertex, you're gonna label it as a point. You have no other choice, okay? It's x and y value. So the vertex is written as h and k, okay? H and k is because later on when we see the vertex form, it represents the h and k in the vertex form. Okay, we're gonna talk about that later. What would be your vertex here?
6.
What's the x value?
6.
What's the x?
Oh my god, it's 3.
1. And what's the y value?
6.
-6. Right? Because it's below the x-axis.
Where'd you find the 1 from?
What?
Where'd you get the 1 from?
Where do I see the 1?
Isn't it
Oh,
above,
okay.
like,
In the middle, in the
when you're
middle.
at 0 there?
There's no number there, so you don't.
They're hard.
I'll just do it right.
See it better now?
Yeah.
Okay.
So you're working with both at the same time?
No, I'm just, for this vertex,
Yeah,
the
where-
vertex for this,
Where you get your one?
it's right here,
Okay.
right? So I'm looking at this point. Just 1 second. I'm looking at this point,
Mm-hmm.
right? This point has an x value of 1 and a y value of -6. Right? So it will be 1, -6. You can't really see it on yours, right? But on this, now you can. Now this is your vertex here. It is the same thing. Okay? So the vertex here is 1, because right it's after the x. You can't see it very clearly, but it's 1, -6. I just want you to remember, I just want you to understand how we write it. I don't care about the numbers right now. I just want you to know how do you write it, okay? And how do you look it. No, because that's -10 right here, right? So that's -5, -6, -7, -8, -9, -7. Okay? So that's -6.
Okay.
And then 1. You don't see it, but it's at 1. And the vertex is the turning point of parabola. The vertex is a very important point. It includes too much information. So in the vertex, there's two values, right? We talked about the values. There are, like, in this case, 1 and -6, the x and the y, right? Do you guys remember what's an axis of symmetry? It's the line where if you fold them on top of each other, right, it will be the same. So it's a symmetrical line that cuts your graph. It's an imaginary line that cuts your graph in half. Okay? So if you were to draw as axis of symmetry, where would you draw it here? It has to pass through the vertex, right? Has to be in the middle, which passes through the vertex. So if I'm going to draw an axis of symmetry here, I'm going to have to draw it right here, right? I'm going to draw it right here. That's the optimal one. So that's all that I need. Okay? So that is the axis of symmetry. So it's a line that passes through the vertex. Because if I actually cut this and overlap, they're going to overlap.
They overlap each other.
Yes. What point does the axis of symmetry pass through?
The vertex.
The vertex, right? It passes through the vertex. At what value? Exactly. X is 1, right? You see that? That right here, I'm gonna zoom this. You see how it passes through that X value, right? So at X equals to what? So when you come to write the axis of symmetry value, you have to write it this way. X equals 1. You see that X equal to is very important. If you write just 1, if you write axis of symmetry 1, you lose half a mark. Half of the mark that is assigned to this. Okay? You must include X equal to. In general term, the axis of symmetry is X equals to H, which refers to this value of the vertex.
So they're related to each other?
Yes, they are. They're the same.
But we wrote down X to identify the answer because I was trying to state what it is that the answer is. Otherwise we'll lose the half mark.
Yes.
Okay.
Because it's the X value that you're looking at. It's an H. Yeah. And the H comes from the vertex. Okay? We're gonna talk more about this later.
If there was a different way to describe it, would it be as if you were looking for certain points on a map, but it's more like you're just finding out the distance in between and then putting it in some kind of open space?
No. You're looking at a parabola and you're looking at its turning point.
Okay.
Technically, that's what exactly what it is. Okay? Alright, now let's define the axis of symmetry. So the axis of symmetry is an imaginary line. That of symmetry that runs vertically an imaginary line that we draw vertically and pass through the vertex. When we talk about optimal value, what do I mean by that? The maximum value or the minimum value. Optimal means it's the lowest or the highest. Okay? So, if I'm looking at this,
Excuse me, what?
the optimal value here is right here. Right? I'm gonna just do that.
Wait, Mitch, can you go back for a second?
We'll go back in a
Yeah,
let me
I
just
did.
explain. So the optimal value in this case is this, right?
So what is that?
It is part of your vertex. Which part of the vertex is it? The X or the Y?
Oh,
The Y. That's right.
So the Y is going like that, X is going like that.
Okay.
This is the Y.
Oh, the line going like that was.
Well, this is the
This
Y
Y.
value, right? But if you're looking at the Y, it's right here, which is -6. Okay?
We'll consider the Y.
Yes. Okay?
So which one we consider the X, if it was going which way?
This is the X.
So,
Now, this is the X-axis,
Right.
right? But the point for the X is right here. Okay? Now, the Y is this, which is -6. That's your optimal value. So that's the lowest point that your graph is gonna reach. It's gonna reach -6, and then it's gonna flip back up. Okay? Is that a yes?
I have a question.
Mm-hmm.
For optimal value,
Mm-hmm.
and why you say the Y is the Y in the bottom of the,
Yeah.
what is the Y say?
Why is it?
Yeah.
Because, what's your point here?
Because the first one was the X, was
That's
the
right.
down there, but now it's Y.
That's right.
It's gonna be-
The first one is an axis of symmetry, this is the optimal value.
That's
Right?
right.
So when you're talking about this, if you're thinking, if someone's swimming and then they went down below the surface of the earth, of the water surface, reached the bottom of 6 meter, and then went back up. What's the lowest point they reach? Is this.
6 feet under.
So you use Y for it.
So that's the Y, yes. Okay? And then that could be, that, in this case, that's your max. Okay? So when we're talking about something that opens up, that's called a min. And something that opens down, it's called a max. Okay? And the way we write the optimal value, we say Y equals -6. Axis of symmetry is X, optimal value is Y. Okay? If I'm going to refer to the vertex, it's going to be Y equals 2K. Right? Because remember that the vertex is H and K. Okay? So if I want to go back to the vertex, this is going to represent your axis of symmetry. And this is going to represent the optimal value.
You don't need to put an on in between those two though. You can just
No,
write
this
it
is
as
a
that.
point. A point, you can't put and. It has to be comma.
Okay.
Can we go back up to the definition? part?
Yeah? I'm gonna write the definition for you.